where we are today with like motor control is much more foundational. It's kind of like, back in the olden computer software engineer days, like we're, arm wrestling with trying to make a little circle travel across the screen. But as time went on, languages allow for more complex things, and then it allows software engineers to do more complex things such as managing AIs, whatever. It's not, none of it is replacing jobs. It's just allowing humanity to advance to more interesting levels and layers.
Welcome to Manufacturing Insiders. Today I have two individuals with me. I have Kyle and Emelia. So Kyle is with a pretty innovative robotics company, a company that's creating a lot of innovation in the space, creating an alternative to hydraulic actuation. And very fascinating work. I think this is going to be really interesting, not only from a manufacturing perspective, but also from a innovation perspective, ways that we can make this world run better. Emelia is with Presidium Manufacturing, and they are making some pretty interesting moves in the manufacturing technology space as well. Emelia is going to be my co-host today, and we're hoping to have her on in the future as well as a co-host. But very passionate about manufacturing, and she's got some questions for Kyle as well. So welcome to Manufacturing Insiders, both of you.
Happy to be here.
Thank you so much.
Yeah, thank you for hosting.
So Emelia, what do we got with Kyle today?
So Kyle has a rare profile in this ecosystem. It was very interesting to look into. He is a designer that wandered very deep into the mechanical landscape, that he has ended up reinventing a piece of machinery that I think everyone thought would outlive us, which is hydraulics. And so he is the co-founder of RISE Robotics. He is the mind behind the Beltrolic architecture, and he is one of the driving forces behind this shift into fully electric actuation in commercial logistics. And if I'm not forgetting, also now Air Force ground support systems. So Kyle, welcome. Thank you for being here, and we're really looking forward to ask you so many questions.
Yeah, absolutely. Yeah. Thank you for hosting. I do have to say, you make me sound much more awesome than I actually am. I'm one of 4 co-founders, and I came up with the Beltrolic name, but the evolution of Beltrolic as we know it is like a total hybrid of a lot of us. So I am not the sole magician behind this innovation, but contribute to it. And
you do have the air of a magician, though.
Oh, thank you. Yeah. It is, whatever it is, as a whole, we are in the game of making something from nothing, or another way of saying it is that we're mixing old ideas to make a new combo. And that goes with anything creative, anything where you are making something quote unquote new. You're taking, hold on. Oh, sorry. Did I lose connection there?
For somebody. Second, yeah, you were right back.
Yeah, when people make a phone call, it cuts out the audio. Okay, so
don't you love that in your car? It's like every time you get a text message, it interrupts your podcast for like 3 seconds for the. It's like, why is this still happening?
Yeah. Why is this still a thing? No one's ever wrote that tech support bug.
Seriously. Yeah. So Kyle, before we get too deep into it, I think your backstory is very interesting and how you ended up here as a co-founder. So tell us about how that all occurred.
So a long while back, I was working at Duro Textiles, which used to be one of the last printing and dyeing manufacturers in the U.S. Due to the very compliant law from the Bush administrations. Anything made for the military has to be made in the U.S. And that was pretty cool. I was there for about I want to say 3 years or so. And then my roommates at the time were getting advice from Aaron Acosta, who was the CEO of RISE at the time. And my roommates were trying to do a startup of their own. And instead of paying Aaron in US dollars, Aaron had in-kind trade request saying that he was looking for somebody that's kind of like a jack of all trades, can do things beyond mechanical engineering, that's into mechanical stuff, can do marketing and all that, and basically help find product market fit in a company that has yet to touch down on anything that makes a company a company. So he reached out to me this one week, and I go up to Greentown Labs, is where Rise was kind of forming. This was around 2014, and it was like, to me, it was like something out of a Disney movie, where it was like all these companies doing all these like really crazy things that I've never seen before, and Aaron and Blake hands me this plastic actuator that looks totally alien, and like, most people would not make sense of it, because it's a shape that I can guarantee you guys is completely alien. I can show you it in a bit. Um, and
Yeah, that'd be cool.
yeah, shortly I realized its value. It's 3D printed and had a bunch of string on it and looked very delicate. But like the first thing that jumped to my mind was like, oh my God, this is like hydraulics. It's like, it's an actuator. It's a muscle. It seems so foundational, and I kind of got hooked. And then Aaron was asking me, he's like, oh, like, what is it that you're up to? Like, are you open for work or whatever? And um, and keep getting text message. And that's why I tell him the story about what's going on at Darrow Textiles, and he's like, "Oh, it sounds like your company's going through a hostile takeover," and I'm just like, "What? What are you talking about?" So I go back to work the next day, and like, lo and behold, my boss, who's the brother of the CEO, he goes like, "Well, I'm fired."
Oh, oh
Yeah,
wow.
yeah, and it's like, it's been in the hands of the family for like 70 years, but not enough military conflict. They had all their eggs in one basket. They weren't diversified into the commercial space, and so they had to close shop. I can go into way more detail, but that's probably for another time. so, so pretty much that week, I'm just like, all right, peace, and I went straight to work at Rise, and it's been a crazy cowboy journey, because, as you know, when you're doing an upstart, where you don't have many of the uh, obvious pillars of what makes a business, you're really learning from scratch. And the only way to learn is by trying things out and failing over and over and over again. And one of our
Mhm.
early investors, Bill Warner, was like basically telling us that, like, a company can fail hundreds of times. Shots on goal is obviously better than not. You find out, fail hard, fast, and the only way for a company to die is if people lose heart. And that's why, if you ever go watch Bill Warner's inspirational videos in the area up here, he's always drilling down on people to investigate what following your heart means, which is very unusual advice for the Boston area, because it seems so analytical up here and so logic driven. And he's like one of the few
Mhm.
characters that's really saying, no, you got to listen to your intuition. You got to follow what motivates you, because if your company can't stick together because of a common dream, you'll just walk away. And when everyone walks away, then no one can raise the money, and then that's it. That's the end of the dream. So one of the main hooks at Rise was like, we're making wearable man amplifiers, exoskeletons, exosuits, but not the types that you see on the news and all the analytical uh, left brain things.
Mhm.
Like where it's like for military or medical, where it's like, it's slow and like big beastly monsters. Like what the initial four of us at the time were totally resonating around the idea of sporting wearable machinery, like machinery that amplifies you. You may have seen anime that kind of celebrates this thing, where you're intrinsically being enabled by an appliance of some sort to such a crazy degree where it can be 100 feet tall. But we wanted something that just allows you to have the sensation of um, mechanically floating, or being able to run across a football field or jump really far while wearing this thing that doesn't hopefully require monstrous tethers to a diesel generator on the other side of the field. Things of dreams, right? Once in a while you'll have a lucid dream where you'll be long jumping over a big field of grass, and it just feels like fun. So that was the common glue. It kind of got nicknamed, that whole feeling got nicknamed as catapult pants, and that's how we ended up just kind of getting our earliest followers, was that sensation, catapult pants. If you can imagine pants being able to give you the sensation of a catapult. It's totally ridiculous feeling, but that's what it took in an image in our heads to have us stick around. And the company has evolved since, but that was the building block to keep us together around a common vision to develop something. I mean, we tried, you know, we studied bearings, flexure bearings, you know, the bones. Like we were trying to figure out of the wearable machine, what is the weakest link. We made a lot of innovation on springs, thinking that helicoil springs were too heavy, but that, you know, and we made these like fiber block based things that were much more power dense than coil springs. And long story short, in various modern commercial applications, that wasn't the problem. The real problem was the muscle, the thing that converts one form of energy to another form of energy, and it particularly the muscle in the sense of linear, either pulling or pushing, was the thing that we couldn't buy off the shelf to make a fun wearable machine. And then, you know, once we did, we're all like, oh my gosh, like this has applicability into things that exist today. There's a lot of things that exist today, like forklifts, you know, that have a muscle in it.
Yep.
And like that muscle is the most demanding aspect of that machine, or say an excavator. And you know, like the more you zoom into these muscles, you realize it's kind of a big deal and nobody really talks about it. So back then, around like 2015, 16, 17, 18, we were saying, oh my God, like it's the muscles problem. And like electrification is happening in cars and like scooters, but why isn't it happening to the really big machines? And then that's where the rest of society will say, oh, we need better battery innovation. We need new chemistry. And then we've been studying the muscles and we say, no, 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 no. No, it's not that's fault. Like batteries are like actually really impressive if you compare it to like, just kinetic fall of energy and stuff. It's how you use that energy is the real problem. I mean, once you start looking at, like an excavator where you have multiple axes, like you're throwing away definitely a majority of the energy you brought along with you as heat.
Yeah.
The same things we complain about a combustion engine, like the used mechanical power after that combustion engine is then degraded by an equivalent amount. They say that gasoline engines are like 30% at best. Diesel engines might be 40%. Well, hydraulics in the best of days will be 40% with the shortest hoses and the best valve blocks. Like, and
That's
in the science,
interesting.
yeah.
I always thought, for some reason in my mind, I always thought hydraulics were very efficient. Like I thought they
If you
used
look at,
minimal energy for. But yeah, I just
yeah,
obviously I haven't studied it. I'm not a mechanical engineer, but so
I actually,
compare and contrast. What with your solution? What are we looking at? What are the advantages?
yeah. So basically, it allows you to more directly drive, like I guess the core meat and potatoes of the technology allows humanity, allows a machine designer to more efficiently turn the ubiquitous rotary motion into linear motion in a very direct way. With
Mm-hmm.
hydraulics, you start off with a continuous rotary motion, you
Mm-hmm.
drive a pump, the pump develops pressure in the system, and
Mm-hmm.
then just kind of like a trumpet, you regulate and redirect the flow of fluid pressure to where you need it to go.
Right.
Whereas in our system, it behaves more like a screw, where the rotations are very proportionate to the output motion.
I
So in the
see.
case of our small cylinders, every revolution is about exactly 16 millimeters of rod travel. So if you turn it really quick, you get really fast rod movement. If you turn it really slow, you get very slow movement. And you know, the core IP itself is like in the 90th percentile, 80, we'll say 85 to 90% efficiency from going from rotary to linear, and that
I actually
transition. Yeah,
really wanted to ask you about energy profiles since you're working with linear actuators. It feels like, and please correct me if I'm wrong, you're building a new way of doing vertical mobility. And on one end of the spectrum, you've got something, let's say, like semi trucks or heavy machinery, where the actuator is doing short, intense bursts of work. And then on the other end, you might have something like an elevator in a high rise where the motion is longer and more continuous. So and heavily regulated probably. So from an
Yeah.
energy and design standpoint, how different is the problem of powering an actuator on a truck compared to powering one
Mm.
on an elevator, or whichever example you'd like to give? But like my real question there is, when you think about those worlds and those applications, industrial vehicles, defense, a hotel elevator, are they all part of the same long-term roadmap, or are those kind of separate in your minds, in your mind?
Um, yeah, well, it's kind of a race to which customer is in the most pain. There are so many uh, actuation machine types in this world. You know, for the last century, a lot of it has revolved around hydraulics. Wire ropes never went away, screws never went away, but these are all components at play, and hydraulics kind of dominate the heavy lifting space by quite a bit. So, like in the elevators, for instance, uh, like 5 stories and below are all dominated by hydraulic elevator shafts, and those will all be driven by an induction three-phase motor hooked straight to the grid that uh, the pump will activate when a command is given. And it is classically in hydraulics, it is the dwell time when if the pump is running and there's no activity being done, and you're just sitting idle and the pump is cranking, that pressure has to go somewhere. So often, like a little uh, pressure relief valve will pop open if there's no actuation being done. So that means all that developed pressure is being sent back to the reservoir, sent back to drain, and that is one of the reasons why excavators are so inefficient, because you have a diesel engine that doesn't like being shut down and turned on frequently. So they have the diesel engine continuously run. And anytime you're not giving the machine any commands, you're venting energy back to tank, which is just developing heat. So you have to cool off the oil with big radiator and a big fan. And yeah, and that's why when you go look at efficiency uh, uh, research papers on excavators, they'll report anything down to like 5 to 20% efficient total machine efficiency
Wow.
because of those dwell periods. So elevators, you know, if you're able to turn on the pump and turn off the pump right when you need it, like that'll improve it. But even then, like you still have valve and throttling losses and all the things that make the machine safe that just come off as heat and friction along the pipes, and then that heat goes somewhere. So it's um, yeah. So
And to
mobile machines,
change it,
yeah,
let's say if I'm if a truck fleet owner and I want all of my semis to have an electrical actuator versus a hydraulic system, how would that look like? Is it from an OEM standpoint, or can I kind of buy it off the shelf and then
I
install it myself?
I can show you the liftgate application is kind of a curious beast. I should hope I hope the Wi-Fi will be good. It should be good out here, but
Yeah, this was so interesting too because the benefits to it are actually a lot more than just the energy or the speed at which the gate goes up and down.
yeah,
Or-
There's a lot to it.
yeah. So this is a lift gate. These are the elevator platforms on the back of like an 18-wheeler, and and with a normal hydraulic lift gate, they're all powered off of the 12-volt system on a truck. So in the engine, you have an alternator. That alternator charges the 12-volt batteries. Those 12-volt batteries are the voltage there is sent back through really fat cables to the very back of the truck trailer, which then goes to about 4 extra truck batteries. And then when you typically run a hydraulic liftgate, it will spike up to 700 amps and then probably idle around 450 amps whenever that pump is active. So just like an elevator shaft, that pump is going to be asking for a lot of power consumption. So no matter the load, it's going to be pulling that much amps. Now in ours, we uh, we can we can essentially proportionately sip from the energy coming from the truck. In fact, we actually, because our system is so much more efficient, because we don't have throttling losses and all that stuff, we only consume what is necessary. So low load, we consume low power, and then high load we consume more power. But because the power consumption is like uh, um, definitely more than half, um, that means we can essentially trickle charge the rear batteries. That's what we're doing right now, where we have the 12 volts come in, and then we boost it up to 48 volts so we can make use of more efficient direct drive BLDC type motors that drives our linear actuator, and we run the actuation that way. We actually also do away with the third door cylinder because we have so much control with our cylinders. We can make the main lifting rams also dual use as the door open and close cylinders. So I'll just demonstrate this. I don't know if you'd be able to hear the sounds because it's very little.
It's much quieter than hydraulic systems, right?
Yeah. Do you hear anything?
No.
No.
So
Yeah, because
quiet.
there's no pump one. So now I'll go down. You should be able to hear this. Oh, nothing. Little murmur.
Not much. Yeah,
Yeah.
the software is picking up a little bit of something, but I can't really hear it.
Okay, cool. Well, yeah,
Yeah, I
that's what
can hear it a
happens
little
when
bit.
you. Okay, cool. So the
A
sounds
little bit.
here. So when going slow, the sounds are going to be very quiet. So if I crawl it, you definitely won't be able to hear it. But if there's any sounds coming out, it's because there's a little gearbox in between the motor and our actuator. That's really where all the predominant sounds are. But when you're closing the door, it's the actuators are moving very slowly, and all the sounds you really hear is just the clanging of the metal going into the latch.
Yeah.
Um, yeah. So as they say, uh, the sound effects are an indication of its efficiency. If there's a lot of sounds, it means there's a lot of wasted noise. Noise is, abrasion or, just
Right.
indications of lost energy. If there's no sound and a
Yeah.
lot of motion, especially pulling under full load, you know that all your energy is being sent to the task of pulling the load, not making sound effects. Yeah.
Have you ever come across an application where the stealth of it, military, the stealth of the operation is a big selling feature?
Uh, uh, it's we do advertise it, but we haven't yet uh, put ourselves in the applications where that would be the main selling point. I mean, often when I was writing the uh, earlier SBIR phase 1 and 2 proposals, I would throw that in there as like one of the nice treats is that because this thing's so efficient, we have a low thermal heat signature and we have low sounds compared to
Yeah.
when you normally run in a hydraulic machine. You hear the whine. We don't have any of
Right.
that. Um, so somehow that turned into, after us making our common lifting device, that was our first military product, this crane thing. This is a manually
Okay.
operated crane that's so easy to I'd I'd turn the knob on this one, but you wouldn't hear any sound effects. Um, uh, there's like a crane hook here, and then this is how quiet it sounds. Oh no, that's going up, and then to go down, I'd have to use two hands.
I heard something.
Yeah, let's see if I could do this without making a laptop shattering scene. I can't get it full angle. Well, you might as well see me turn the crank. It's going down.
And what was this used for?
This is for taking out line replaceable units for the I don't know if I can say the exact
Yeah.
piece that comes out of the nose of a C-130
Nathan
MJ
asked the right
C-130.
question.
Yeah, yeah.
Who's that for?
It's a line replaceable unit, and it's very expensive, and it
I'm always
must
trying to get
be
classified information.
yeah, yeah, and it has to be serviceable no matter where you are on the planet, and the usual method would involve ladders on the airplane, and that's not good.
Right.
And it requires two ladders and two people to lift this 250-pound object and bring it down. That's just not great. So if they had some sort of a crane system that can stow in a very small form factor on each of these airplanes that have this item, that would be great. And the fact that it has no power source on it means that it will probably work when they need it to, no matter what. And so it sits inside of the loading door, the main door on the C-130, and it's just kind of out of the way. And it's like, it's yeah, it's one hell of an insurance policy. And it fits inside of a small 3 by 3 by 6 foot box. So right now it's all
Oh, wow.
built out, but it origamis into a tidy little package. And like I say, the manual nature was very exciting. There's other cranes that do things similar, like this yellow thing here, but it's much heavier, and it pulls more load. It has a different capability set, but it is very, very heavy. This thing here weighs 200 pounds, and it basically picks up 200 pounds. And that's exactly what they're asking for, is like a very lightweight, nearly like a bicycle like thing. And we could do that. We don't need a crazy gear train because we're making use of elevator belts, which can run off of very small pulleys, which means you can get like really nice small, like great mechanical advantage, and it doesn't require a Herculean arm work to do that. If you had a mechanism that was more inefficient, you would need more effort. So
Right.
yeah.
Right.
Speaking of force and power, when you remove the liquid, right, because
Yeah.
traditional hydraulics is essentially the compressibility of the fluid, what becomes the limiting factor in your ability to generate force, that the force envelope, I guess?
There's the there's the maximum allowable belt tension, and
The
then
belt.
and then there's the bearings. Those are the two. Those are the two things at play. I could show you our smaller cylinder, just to give you a sense of intuition. These smaller cylinders, which they're current underneath like a rebuild right now, but of this size, if you can imagine, that's about 4 inches outer diameter. Um, they kind of look like that. There's the drive end, so that's where our quote unquote pump box would be, and then about 50 inches of stroke. This is what goes into the lift gate, and that motor that's on it is actually basically underutilizing the capabilities of the belts that would go into this. So the belt itself, the single belt, can pull, we'll say like 500 pounds. That's like the maximum rated tension. And then the bearings can, we've designed them to outlast many belt replacements. So it really comes down to the belt's ability to handle tension. And the bearings themselves can spin up to 14,500 RPMs. So if you know your fastest pulley speed and your maximum rated load, that means you shouldn't put in more than we'll say like 50 Newton meters into the input of the machine, which if you do that math out means that these size actuators can technically handle, once at speed, once you accelerate without over tensioning the belt, once you get up to speed over the length of the stroke, that means you could technically stuff 100 horsepowers of mechanical work into the input. So like while these cylinders seem small, 100 horsepower is insane. I mean, like a common electric motor might be like this big. There's some new motors coming out that, like, we have some in the back that are, this big, that can dish out 100 horsepower, and our actuators would handle that. Now, who the heck wants to go that fast? It's never been an option in machine design to have linear actuation move so fast. Like hydraulics will have packings rated to 1 meter per second. Ball screws and roller screws can touch on 1. Roller screws can go up to 2, but you shouldn't go any further than like 16 inches of stroke for an equivalent force, because you'll experience whip. So generally machines, if they wanted to go fast with linear actuation, try to stay below 1.5 meters per second. This one would be able to go up to 4, knowing the bearing's max rotational speeds and the fact that elevator belts, well, they're designed to go. I mean, look at Taipei 101. That's a flat belt elevator shaft. That thing moves very fast. It's like a car tire. A flat belt is a car tire. So you're rolling at the speed of a car. So so when you now think about heavy machines, go ahead.
The repercussions of it are, I mean, huge. I just, I think about the excavation space.
Yeah.
When you're able to, and we already discussed this, but I really think the future of excavation is going to be all computer controlled. Instead of having an operator in there, you're basically going to have a 3D model
Yeah.
of what you're trying to build. You're trying to dig a pond. Here's the dimensions. Here's the depth.
Yeah.
Here's what it looks like. Upload it into the excavator, and it goes to work. So that's the future of the way that's going to work. But the limiting factor is still the speed of the machine. And so now you take the operator out of the picture and the speed at which he can operate.
Oh yeah.
These things can just fly through that job.
Oh yeah. Yeah, absolutely. I mean, it's like the same line of reasoning why 3D printers have such great commercial success. Like it allows the, for a certain amount of money for you to achieve a certain amount of autonomy with the press of a button, and then the machine just kind of does it with minimal crashing into itself.
Right.
Versus like a guy in front of a Bridgeport seeing, trying to manually do what a CNC does. Like it's pretty clear that automation will, automate some things that are worthy of automating. So if you're digging trenches, like, or like, say if you have like a crummy driveway and you're trying to dig little moats on each side to allow water to run off of that, like I could sit there with an excavator and learn how to do it like a proper person. Or you can just have the machine say, follow this road, I'll it just follow this line, just cut 2 feet all the way down. Like that would be great. And like do it like a pro, and don't waste time, because like getting diesel from down the road up to this machine is a pain. So can we do this with less, contractors?
Right.
Yeah, like all those things really make obvious sense. But then even if you, like, autonomy aside, if you were in that excavator and you were a newbie, it would sure be great to have a machine that isn't limited by the operator, right? If I just like, if somebody was untrained and just jumped in a big excavator and started jamming the pedals, like you could make the machine buck. You could make it do things that will hurt the machine.
Right.
And a trained person wouldn't do that. They would know how to not ruin the machine.
Right.
And
Yep.
that difficulty learning curve shouldn't exist if the machine is designed properly. Or you spend a lot of money and there's a lot of like, things in the way. But if the excavator could behave more intuitively, kind of like a what do you call those, pentagraph? Like a thing that copies coins, or you start like with a big sculpture and then it scales it down to a small coin, like how coins are made, like a pentagraph.
Okay.
Like, if I move this joystick a small amount, the arm over here that is like 100 times my size moves proportionately, and I can feel the force feedback if it runs into something, or if I run into something, it feels it. It's a one-to-one relation.
Right.
Like if
Yeah, that's really
excavators were
cool.
more intuitive, it would enable
Yeah.
that kind of sensory. So for operators, they would only be jazzed, principally because we don't have that today.
Right.
So
Right.
there's much to do in this space,
Right.
automation or not.
Yeah.
Yeah. Like, would it be
Um,
great if you were digging with the excavator and then you hit a pipe? Today, you wouldn't feel the pipe. You would hear and see a metal clang and then a burst of water. But if you can
right.
feel, just like your fingernails raking through sand in a beach, and you run into a crab or a shell or something, you would go,
Yeah.
a thing is here. Don't go. Like we don't
That's
have
a
that today.
fascinating concept. So
Yeah.
in what way do you feel that your technology would facilitate that?
Yeah. So because it is above 50% efficiency and it's direct drive by nature, because it's 90% efficient at the conversion of rotary to linear,
Yep.
it would allow the electric motor to feel things that are happening, haptic feedback. Like it would, like the fact that we can push on the rod. If we pushed on the rod, it will actually back drive the motor. It'll spin the motor. Or if the motor spun, it pushes the rod as you normally imagine it. But it's like an electrical transformer or a lever. Like, the proportionate action happens here as it is over there. Like it's just a lever. It's a new type of lever. So with brushless motors, you can measure the current, and if current goes up because suddenly you ran into some rocks or something, your motor would go, ooh, like I feel it.
Mm-hmm.
It would be able to,
So are
then
there sensors equipped on these rods that are transmitting data to, let's say, an operator is just watching that happen?
Yeah, well, there's an absolute linear position sensor that tells you exactly where the rod is in space, and then there's at the motor there's a rotary position sensor, and then there's also the sensory organ capability of the motor understanding how much current is coming to it or going,
Exactly.
coming in, coming out. So between
Yep.
those three, the the whole system can get an understanding of where is it in space, how hard is it working, something happened that wasn't normal, and you can then back drive out of that like haptic feedback or whatever it is, and
And
that's not. Yeah.
how are you managing or maybe planning on managing that feedback loop so that the data that is received from these sensors that you can improve it the next time, make sure that if it's going to send too much energy that it doesn't do that the following time, kind of this deriving value from the data that these sensors provide. How are you guys handling that?
Well, classically, just like any machine with a motor, like you have a ECU, VCU, vehicle control unit, like you have like a central brain that communicates to all the actuators, all the sensors, and like the embedded engineers would have to make sure that all these processes all communicate across one another for a complete safe experience. I mean, like in manufacturing, you have those PLC control
Right.
boxes, and like there's like ranges of normals, and then if you go outside of that, then you flash the red light or whatever. I mean, same thing happens uh in the machine. Okay, good. Now I can hear you. You can hear me. It's going through the
It,
head.
it's perfect. Okay, so where were we? What was the last thing that was said? I'm trying to remember.
Haptic feedback. Feedback. Um, oh,
Mm.
oh, having the harmony of sensors.
Yeah, you were
Like,
you were answering Emilia's question about the feedback mechanism, the sensors.
yeah.
If you remember roughly what you were saying, I'll mark the clip and then you can get right into it.
Okay. Well, yeah. So essentially, um, having motor current feedback, absolute position sensing. Knowing where the rod is in space, knowing where the motor is in its rotation, its clock cycle, and then having it go to like an electronic control module, a central brain, a vehicle control unit. That's all normal. That all modern, cars have this. Even hydraulic machines have uh, VCUs. These central brains. Um, when we prototype, we might use something like a Raspberry Pi or an STM32, but this is all normal practice in going towards the ultimate ECU, PLC, VCU, and that takes a little bit of time. Making sure all the code is firing in proper order, super efficiently, very fast, tight feedback loops. It's nothing out of the ordinary. It takes time, and then one day AI will uh, make sense of it. I don't know if you guys ever saw the movie Chappie. Chappie, when there was like Ex Machina that came out, and then there's Chappie. They were
Mm.
like released in the same month. Oh,
I
okay.
didn't
Well,
see it. I didn't see, but I do know.
Another
I,
one's
I do
building.
remember seeing about it. Yeah.
okay. Yeah, they're like all the attention was on Ex Machina, and I'm just gonna tell you in the audience that go watch Chappie instead, as far as like enrichment of understanding how machines or even nature grows and adapts and learns. Um, don't watch Ex Machina. It's not good. It won't give you you won't intellectually grow from it. That's just my 2 cents. But in Chappie, like it's they play out the analogy where somebody uh, one of the coders to these autonomous robots gives it a more of a natural, like a natural machine learning software script in its head, and it once it starts like a baby where it sees, it hears, it feels, but it doesn't know how to use its arms, its legs, and limbs. And, you know, somebody pops into the screen. Somebody's trying to be friendly. Somebody's trying to be aggressive. And like the pile of parts has to try to start to coexist with these inputs and sensors. And after a while, it can learn how to move fingers, and like develop a sense of consciousness per se. And um, to me, that's kind of like machine learning in general, where like you give it like a pile of information and then it kind of finds patterns in it. And then after a while, it's able to actuate and make use of the patterns and like do more and more complex things. And that's what motor control will eventually be, where you, say you weld together a bunch of parts and pivots and you put these actuators in place and there's a lot of sensors and they come to this central ECU that has this uh, machine learning brain in it, and it should be able to, just by delicately trying things out, understand the inertias and the limits and the end conditions to the point where it will know what hurts and doesn't hurt. And after a few, maybe a day or less of just trial and error, it will know its capabilities, and then not and it will help simplify the embedded engineer's process of trying to get the basics going. And then that will allow embedded engineers and software engineers to basically focus on higher, more complex tasks that the machine might want to do, like doing backflips and things. But
Right.
where we are today with like motor control is much more foundational. It's kind of like, back in the olden computer software engineer days, like we're, arm wrestling with trying to make a little circle travel across the screen. But as time went on, languages allow for more complex things, and then it allows software engineers to do higher, more complex things such as managing AIs, whatever.
Yeah.
It's not, none of it is replacing jobs. It's just allowing humanity to advance to more interesting levels and layers. So,
That's a great way to put it. I think it's one of the most important things as AI gets more prominent in our daily lives, for people to remember that I think we have this incredible ability of making technologies as a human race, and we haven't been out of jobs yet.
no,
We've
yeah,
always found some way to adapt. I think it's one of the best things about the human species is our adaptability to change. And when we are adaptable to change is when you see no progress in something like manufacturing in the United States for a long time.
yeah,
I really wanted to ask you. I know we touched a little bit on kind of those new and better capabilities that you're bringing. I know the Air Force is notoriously obsessed with weight,
hmm
uh, energy efficiency, logistics
hmm
footprint for sure, and hydraulics comes with all of the things that they want to avoid on
oh
paper,
yeah,
at least, right?
yeah,
The
uptime.
fluid,
Like you
yeah,
want
the fluid
reliability, right?
handling.
Yeah.
Yeah, and those maintenance hours, you're working with any type of fluid, you have a risk for leaking and just a lot of support infrastructure. And so given the way that Air Force evaluators are,
hmm
what do you think that they actually responded to, or best responded to, or what helped them trust in your guys' system that at the end of the day breaks away from something that has been around for decades and is reliable?
Yeah, well, right out of the gate, and they've been saying this, and you know, talk to any operator or look at their dull swords report. Anytime a machine goes down, and downtime is a problem, at any given
Mhm.
moment, there might be a percentage of the fleet that is down that needs repair from the age shops, the aerospace ground support equipment shops. Like, people have to wrench on these things to keep it alive. And they were designed in the 50s, and it's all bolts and hoses, and not everything can be fixed. It's just a matter of time. But that downtime, it's like, it's
We're
like
killing.
it's a trackable statistic, a KPI that's like a thorn in the side of operations. It has a dollar amount. You have to assign people to it. It's definitely painful, and there's no
Absolutely.
way around it. They tell everybody that all their problems, at least with the MHU-83, the thing that we're aiming to improve upon, has, like, if you all the problems are hydraulic related because it's all hydraulic, hydrostatic drive, hydraulic lifting and actuating. Um, the only If it ain't leaking, it ain't working. The way they know if a machine like that is good to go is if they look underneath the vehicle, and if it's dripping at a rate less than 10 drips a minute, then they know it's good. If it drips more than that, then they know it's just going to be a slip hazard and they can't put it into work. So like it's
Uh,
always leaky. And then when you open up the hood, there's many hoods on these machines. When you open up the hood,
mhm.
it's like a science fiction's rat's nest of hoses and valves, and the leak that you saw when looking underneath the vehicle does not emanate from that exact point. Liquid drains to the lowest point. So like a drip might come from one hose, jump to another, and it's you can talk to anybody that works on these things and they'll let you know how annoying it is to troubleshoot the problem. Sometimes it's quick, sometimes it's weeks. Oh, and
Yeah.
then getting a replacement part is brutal because like it was specialty made for them a long time ago, and there's no
Mm.
commercial secondary usage for these machines. So like you're at the behest of the manufacturer who's
And the guy who retired, and they have to
yeah,
call him. He's like, "Hey, I've been retired for 15 years, but we
yeah,
really need you to make this thing."
yeah. So like, there's other companies that are racing to try and improve their complaints on this machine. They want to modernize this machine. They don't want new patches to the old machine. They call that new old. They don't want any more of that. They already done that. They want a new machine that solves these problems that are, you don't have to look far to see it. Like in the statistics, they tell you what's the biggest problem. And still today, the big OEMs from all around the world says, "Ah, we've already designed a perfected hydraulic machine." And then when they look at it, they go like, yeah, but it still has the things that we wrestle with. Like,
Right.
is there anybody that can not do it with this fluid power thing because of the cost of this? And like, we're the only people that have jumped out saying, hey, we can do this purely electromechanically with with
Yeah.
grease at the most, bearing grease. And then they're all like, oh really?
That's
Like,
Yeah,
tell me
I
more.
have such
Yeah.
a soft spot for companies that, they look at something that existed for maybe even longer than the time that they've been alive, and they said, I could focus my energy on maybe making this better, or should I sit down and do a bit more of that engineering work? Not only the engineering work, actually, because you also have a market uh, adaptation to handle. The go to market strategy changes in a way of it has to go hand in hand with some education.
Hmm.
Right.
Mhm.
So what would you say is kind of how the way that you guys handle it, a bit more from the business perspective, I guess,
Yeah.
and for your answer, what was that hardest part? Maybe educating people, or what was that, data point that you would say in every pitch, that
Yeah.
says
Yeah.
that this is why it's better.
Yeah. I guess from like the highest level, and it may just be the most universal one, is that you just have to be like constantly, well, maybe it's a 50-50, but you must be constantly talking with the customers. It is very
Hmm.
easy to say, I know everything that the customer is going to say. There's nothing I could possibly learn by talking to the customers because I think I know all the problems and I know all the problems. I know all the ways in the way our stuff will fail. And if I could just perfect the thing, the locked state in my mind, like I know it'll sell itself. It's not true. You have to get that bad behavior out of your head. You must iterate with the customer in faster and faster intervals. That's like the general rule of thumb told to me. I experience, I see. Life is better if you can quickly do B plus jobs as faster and faster. And this shows itself in time and history. Look at World War II and its machine design. That's plenty of that. You got to try things out. You got to find out. You got to do quick, fast little experiments.
Is
And
that
then
kind of
sometimes
how you were able to develop like the liftgate, for example? I mean, was there some of that iteration working with the customer,
some of
or
those
was it?
revelations are discovered in the process of trying to bring our tech into the liftgate.
Yeah.
Like, and each time you try something or go through a process, you kind of have an intuition where it's just like, oh, I should have done that back then when we had the chance. But we had to try out this way first in order to have a feeling later that it should go like that. The liftgate
Right.
we've had the most time with as a single application. So we're pretty intuitive with all of the ins and outs, the way other competitors, other OEMs design their gates, how truck operators talk about their gates is going to be very different than the way fleet managers talk about their gates between brands, how they
Right.
feel in the snow. Everybody has a different opinion. And it sounds overwhelming and like you'll never get to the bottom of it. Even if you write it out in an Excel sheet, you will um, see things that are not apparent. And sometimes, like the things that you, the company, is uniquely capable of doing, that's really, or there's the things that you're uniquely capable of doing, and then there are the things that you kind of brush off because it's easy. it's not your pain, it's not your focus, but it's like something that you could do very easily. Sometimes those easy things that you brush off are exactly what they are asking for.
Mm.
And
Yeah.
and the bar could be surprisingly low, and you just won't realize it until you listen deeply to like what they're actually complaining about. Because it's very easy to try to push your technology onto people
Yeah.
because you're trying to say, hey, I've got protected IP that blah, blah. But like sometimes like the key answer to all their life's problems is like something simple, and so
Right.
So true.
yeah. But yeah,
When
yeah, go ahead.
Sorry if I can cut you off.
Yeah,
When you think about the long-term impact that you guys can have, and I don't want you to piss anybody off here with your
yeah,
answer,
yeah,
but
yeah.
what part of the hydraulics ecosystem do you think, if you had to guess, would disappear first that
Oh
you
man.
guys will just replace?
Uh, hmm, that's a really great question. Because like in our like even in our own team, like when you have engineers, like the natural reaction is like there's always a place for something, you know,
No.
like hydraulic
And they
brakes make so much
and
more
they want
sense,
to
you
gravitate towards what's cool, right? Like the
know.
Iron Man suit, or you know,
Yeah.
maybe not the biggest need.
Um, like what segment of hydraulics would disappear if we were to start to be more ubiquitous?
Hmm.
That's a hard
Like
one
in a
because
perfect world where you had
yeah,
all the resources that I can hit every industry that my architecture, my tech will fit, which is the one that probably needs it the most, or will be the most receptive to receive. The scalability aspect of it is an interesting kind of way to think about it as well, because not only you need to be able to scale it well in people's infrastructure. So
yeah,
maybe that helps their answer.
Yeah, and I
yeah.
would look at it from the perspective of like, number one, what is the most widely used applications, top 10 list of hydraulics? Okay, out of those, which would most benefit from speed
Mm-hmm.
and which most suffer from maintenance issues? And then all of a sudden you're down to two, and then,
Or the
okay, there's
heat.
your marketing
Yeah.
strategy.
Right, right. Well, there's popularity and then there's runtime. So when talking about like efficiency, productivity, like people who care about fuel consumption and uptime might not be the most commodity applications. So if you had, um, so like, so like, Bobcats, for instance, will be
Hmm.
very high volume. Many of them are sold every year, but
Mm-hmm.
the amount of hours accrued per year per machine is very low. Like they're kind of like for home,
Hmm.
like, not high productivity operations. And as we break into the market, we like it'll be hard to compete in high commodity applications because those are priced at such cheap prices in order for common people to buy it. But
Mm.
areas that and then on the other end of the spectrum, like mining equipment, where it's like only like 10 whatever big trucks are made per year
Hmm.
and they cost like whatever
Bitcoin.
millions of dollars, like those things
Hmm.
need to work around the clock. Like downtime is unacceptable. Fuel price or electricity price, because usually they're put next to a dam, a hydroelectric dam.
Yeah.
Like every nickel counts, kind of a thing. And the bounty for those are very high, but very low in quantity. And classically, in history speaking, any improvements over productivity or fuel consumption gains is usually seen in places like mining, like where it's where it's extreme like that. Like if you have something that money can't currently buy, like productivity, like if you
Hmm.
can have actuation systems that go like twice as fast or whatever, like mining will probably be like one of the people that will leap out of their chairs if the claims are
Mm-hmm.
true, kind of a thing.
That's a great answer.
Yeah, so like the sweet spot might be in the middle. We Doug Pedersen, who used to work for us and worked at Caterpillar, was like basically identifying that there is a sweet spot in which it's kind of like in the knee in between those two. And I don't want to share it there, but it's a machine that I am so in love with. Yeah, but um, uh, yeah,
I would love to give you the opportunity to maybe give some advice to the people that are listening
yeah,
in the sense of from the background and from the story and how Rise Robotics came to be and how you entered that market. I think it's a very interesting story. I think there was a lot of pivoting that was
hmm
involved,
oh yeah,
kind of trying something, putting effort into something, and then going and saying, maybe this is the wrong direction. Am I pushing in the wrong direction? And I've
yeah,
seen a lot of people, a lot of companies hit a dead end and either
hmm
double down out of desperation
yeah, yeah,
or quit altogether.
yeah,
And
yeah.
so when you went through
hmm
multiple phases, what would you say? Like, how did you know it was time to stop pushing in the wrong direction? And how did you make that decision, you and your team,
Oh,
without letting ego get in the way?
yeah, that's tough. Yeah, it's kind of like the triangle of like what, like, because sometimes it's natural to be looking. There's like the present, like what you're prototyping, the Frankenstein, enough to like get that traction with a customer to say like, yeah, I'll look at what you guys mocked together that looks like a product. And then the first reaction will be like, well, it's kind of expensive, compared to all things considered. And then it's very natural to say like, oh yeah, but like at quantity X, like, that's when like the prices seem much more manageable. But like,
Mm.
Right.
you as you're developing your product, you're trying to um, really not be in hopium mode to be so far down the road by looking at like quantity 100,000 and saying
Hmm.
that like you have to bridge the gap incrementally all along the way. You can't just be putting all your hopes and dreams at a quantity that's unrealizable
Like,
given.
does this business model work at
Yeah,
this huge quantity? Got it.
Did you
yeah,
say hopium? Hopium?
opium. Yeah, yeah.
I
As
like
you're a
that.
startup, like
Yeah, like you're on here.
you got to have some belief in what you're doing.
Right.
Like if you don't have the answers now, what is needed to like like what do you need to know in order to get to more confidence? Like
Yeah.
you will be in that position all the time, and it'll be an unsatiable appetite because you'll always be in that mode of like not having enough uh, information to have a good judgment. Will this work? Will this not?
Right.
And so and then sometimes your projections of like the cost at quantity will just be Im- impossible given what the market is willing to bear in the present. And then those are the times when you have to go like, do we have to start from scratch? Do we want to keep pursuing this market? Do we love this market? Like, are we going to lose steam? Like, do we still
Hmm.
believe in each other? Like now knowing what we know about our thing, like, is there a way to jujitsu this into in a more appropriate field that we already have warm leads to? Like, like how do we not tear down the whole building in the process of pivoting? And,
Right.
that's just,
Yep.
it
Which
feels
I
bad,
think,
you know?
it's such a great question because a lot of companies make that mistake on some level. And what one way I see it a lot of times is they go out and buy a, $5 million machine. And, maybe they wanted the latest, greatest 5-axis machining center. And, but they don't have the work to fill it up. And then it
Mm,
sits there. And,
yeah, yeah,
so I think a lot of companies are prone to run in the wrong directions.
right.
And especially when you're sort of in in an innovation space where you're breaking into markets, you need a mechanism to assess what the market need is for what you're offering.
Yeah.
Um, and the thing I advocate for that is digital. Like we
Mm,
have tools. We can evaluate search volumes for different variations of keywords, and we can kind of figure out what people are looking for, where they have in the problems before we invest the money in the equipment or in the,
right.
the process. But no, I
hmm
think that's great. Just to reflect on and to think about how you can avoid making costly mistakes and going too far in the wrong direction.
hmm Yeah. I'd like to know if you, if anyone, I mean, this is like the holy grail of uh, uh, the the nature of business.
Yeah.
Things are always changing. You always, only the paranoid survive. You got to be checking yourself
Say
before you
this
wreck
all the
yourself.
time.
Yeah. No, yeah, that should never go away. Yeah, that's healthy. But I
Yeah.
feel like sometimes we've been taught to think that that's not healthy. It's like, no, you got
Yeah.
don't be so negative. I don't know. No, it's real.
So are you guys you're in growth mode, or are you in refined product mode and then growth mode? Like, what do you feel like you have something you're ready to bring to market? You're ready to just ramp up sales, or where are you at?
Um, uh, well, I would say mm, growth for sure. Like we have like mastery of this totally new transmission method that is working, and some of the things that we are like arm wrestling with as we work with customers are like um, components that surround the IP, and it sprawls, right? Like sometimes like a customer may have a unique power plant situation that we have to interface with that they don't know how to jump the gap between their generator and our inverters. And like, every company has this integration complication, and every application is so unique. Some want it really fast, some want the reliability, and you can only find out by trying it out with them, and it's like it's
Mm-hmm.
painful because it's never like drag and drop simple.
Right.
So I don't want to say it's custom, but like belt hydraulic means so many different things to so many different people.
Mm-hmm.
Like it really has all these like all the things that we advertise that you've probably seen on the internet. There's like too many, and then for each machine type, each customer out there, they just probably want one of those many flavors. And it's like a
Mm-hmm.
tape cassette thing where you push one down and something else pops up, and like, yeah, and yeah. So while it seems universal, it's like you know, like in oil and gas, it's like speed. But for like, lift gates, it's about uptime.
Mm-hmm.
They almost don't care about speed. The speed is cool, it gets them like interested, but like,
Yep.
it's like if they could do anything to solve their uptime conundrums, like that'd be nice. Or like, well, I mean, a part of that is the power supply, killing the truck. If
Yeah.
they could solve that, that's like their bigger problem. And we do have a unique advantage where we can actually control how much our system sips off of their machine, whereas no one else could. So it's like, and like the more you zoom into any one application, you get so high res. It's the only, yeah, yeah, you find out exactly how belt hydraulic means to those people, or like how belt
Mm-hmm.
hydraulic means to the Air Force. Yeah, it's quite the
Yep.
journey. There's,
It
yeah,
is.
I wish it was a more simple answer, but it's dynamic like that.
It never is, right?
Yeah.
Well, I really appreciate everything you shared today. I think you have some great insights. I love the way that you think about things. You're very analytical and obviously very educated, and I can tell
Oh,
you
thank you.
you read books and you know some things. So it's very fun chatting about it. Love to hear about these innovative ideas, and I fully expect that one of these days I'll be walking down the street and see your hydraulic solution on a dump truck or on a
Yeah.
excavator or something to that effect. But
Yeah, I would.
thank you very much.
Yeah, I would love that. I'm here for the toys. Yeah, it will sound a lot more satisfying when those exist. You just got to come
Yeah, and Kyle,
and
it
see for
was
yourself.
yeah, it was so nice preparing for this. Until now, my only true first-hand experience with hydraulics has been from general aviation. The small airplanes use hydraulic brakes.
Yeah, yeah, yeah.
But stepping into your world for this hour really expanded that frame. Thank you for continuing to work on the technology that is so ingrained into machines that touch our lives. And I'm really excited to see where you guys scale.
Yeah, awesome. Well, thank you for tracking the crazy adventure. It's cool to know that we have fans. I could tell you,
Yes,
or
well,
at
you
least,
have two more
yeah,
now.
that's great. Yeah, I mean, man, I'm sure every startup or anybody that's starting anything feels like they have no fans. I still feel like that. It's like, ooh,
I
it's very
felt that way
lonely.
for a long time.
Yeah,
I'm still there.
yeah, it's cool. It's mutual.
Yeah.
Well,
Yeah, thank you
thanks
guys.
again for coming on,
Yeah,
Kyle. Yep, appreciate it.
yeah, thank you for letting me tell what little of the story I've got to tell.
You're very welcome. No, you did great.